Good morning, everybody. Welcome back to COVID Computer Camp. It's part 2 of our Galaga clone today, and we're going to continue programming our enemies to make them do some swirling, shooting, cool type stuff. So let's get to it. Alright, so we programmed the first block of code here for our drone 1 enemy yesterday, and mostly what we were doing is creating a bunch of clones. So we created a number of bad guys that's keyed into the number of the round that we're playing. So in the first round here, you can see that we are creating 5 of the drone 1 bad guys, but we're also creating those drone 2 bad guys that we're going to create a little later. They're going to be able to make us shoot, and then 1 of the drone 3s, and then every round there will be 2 more of the drone 2s, 1 more of the drone 1, and 5 more of the, you get what I'm saying here anyway. So every round the number of opponents you're going to face is increasing, and then we wait a few seconds, and after all the guys have swirled and gone off the screen, which takes about 7 seconds, we change to the second round, and we keep going up by round. So there's no lives in this version of the game, as I said yesterday. It's just you stay alive as long as you can for how many rounds you can and see what kind of score you can get. And every time you die, the game will reset itself, but you don't have to hit any buttons. It'll just start you over again on level 1, and you just want to see how far you can get in it. Okay, so we're going to start a new block of code here. So we're setting the stage for something that's going to be happening later. As I said, our enemies are going to go through a couple of different stages as they move onto the screen. First, they're going to swirl onto the screen. They're going to land and hover for a while. While they're hovering, they're going to be kind of in formation. They're all going to be moving left and all going to be moving right. And we have to figure out how to keep them all moving in synchronized motion. And so what we're going to do is have another invisible object on the screen, and I believe we've called it the enemy grid. And that little object that we're programming is going to gently move to the left and right, and everything else is going to base its motion on that. So while it's hovering, everything else is going to gently move to the left and right at the same time. So we have to do some stuff to set up this grid. There's a little bit of math that's involved, and I wanted to talk to you about that before we really get started here. So we're going to be using a very complicated, well, complicated for kids your age, function from a branch of math called trigonometry. Okay, trigonometry has to do with like Pythagoras and the relationship between angles and a triangle. It's complicated, but it's part of the way that geographers and engineers work with finding distances of stuff when they can't actually reach it. You can measure angles and distances and do some math and figure stuff out. You don't need to know any of this today, but I want to show you how we can use a little bit of this complicated math that you guys can paste into here and use it to create some more smooth motions that we can't do with normal math. Let me give you a good example, guys. So I've got a project here that just demos what I'm talking about. I've got a bad guy, and what I want is these guys to be moving left and right. So I've created a simple little script here that tells them move left 30 times by 1 pixel, and then when you're done that, move right. And let me show you what that looks like on the screen here. We'll just maximize it. So our guy is moving left and moving right and moving left. We could do that in the code, but there's a better way to do it using a little bit of advanced math, and let me show that to you right now. So over in this sprite, we have something called a cosine going, and this is the code that we're going to be using kind of in our game in a second here. So what we're doing the same kind of thing, but we're spinning. Let me show the guy. So this purple guy here, he's spinning around, and he's just telling the clone that he makes. So he's going to make a clone of himself, and that clone is going to move using some math that goes off of what direction he's facing. So as he spins, he's sending information to the other character about how he should move. I want to show you what this looks like, guys. So this guy here is moving using this formula, 30 times cosine of direction. You don't have to understand the math to know to see what's happening here, though. So he's moving left and right, kind of like the green guy is, but the difference is he's doing it in more of a pendulum motion. He speeds up as he comes back this way, and then as he gets to the end of his swing, he slows down, and then starts again and goes faster, and then slows down, and then goes back again and goes faster. And so it's not a huge deal. We could totally do the code this way, but I wanted to show you how just adding a little bit of advanced math can often give you much more realistic graphical effects. And you'll see the difference when we're playing. Everything would just look very, very smooth and lifelike and natural. So even if you don't understand this cosine function and what it does, just trust me, we're going to use it inside the code here, and you're going to see how it makes our game look a little bit more realistic, which is what we're shooting for, of course. Okay, so we got to set this grid up now that I was talking about. So let's go grab a green flag. Let me bump that up in size a little bit here. And we're going to say forever. So let's grab a forever block from our control. This looks a little small. I think my magnification's off here. There we go. All right. Now, inside there, we're going to get this reference object, the drone that is going to be making, so this is the mother drone that's going to be creating the clones. He's going to be spinning around and sending that cosine information out to the other clones that it makes. So the first thing we have to do is get him turning around. So let's go to our motion here, and we'll go turn to the right by just 4 degrees. Now this angle that our ship is spinning at actually determines the speed of the oscillations. Let me show that to you one more time on this project, this test project I was showing you. So you can see we're doing the same thing. We're turning 4 degrees. If I change the amount that we're turning here, if I go with a smaller number, for example, our guy's going to spin slower, and this oscillation is going to slow down too. If we go with a bigger number, like 20 or something, you're going to see the oscillations much faster. So we're controlling the speed with which this thing swings back and forth by changing the angle with which that object is turning. It's complicated, guys, and you don't have to understand it. Don't freak out here. All I'm saying is this is what controls the speed with which the things move back and forth. And so you can change this number around and get different kinds of oscillations. An oscillation just means a spin back and forth, right? Okay, so let's set a variable here. We'll go to our variables, and we're going to go set enemy grid X is the name of our variable that's already been set up for you in the starter file. Those of you who are having trouble getting started, by the way, let me paste the working file into the text messages here in YouTube, just in case anyone needs to catch up. All right, so we're setting enemy grid X2, and here's where the math comes in. We need a multiplication sign. So let's go to our operators. We'll grab the multiplication sign, which is the third one down in our operators, the little star-shaped symbol. And we're going to go 30 times cosine of direction. So we need a weird block that says cosine. We're going to find that down at the bottom of our green operator blocks. There's a function here that says abs of blank. That was the one that contains the cosine. This is actually where all the super complicated math functions are. We've got floor, ceiling, square root, sine, cosine, tangent, and logarithms, and all kinds of other stuff here. This is the stuff that you learn in advanced math in grade 11, 12 math, and even first year university math. So they're using Scratch right now, even at like Harvard University. If you're going to go take Computer Science 101 at Harvard, you're actually going to start working in Scratch before they let you near Python or C++ or any of these other languages, because all of this math is in there. Even though this is a kid-oriented tool that's really great for kids, it also has some great stuff in advanced math, which you guys don't have to know yet because you don't have to worry about it. But just follow what I'm doing here. So we're going 30 times cosine, which is cos of our direction. So I need to go find a blue block under motion here that says direction. It's right down at the very bottom of our blue blocks. Let's pop that in there. Now, all we're doing is making this guy wave back and forth. I don't think we're going to be able to see him here because he's invisible. Let me show him. There he is. He's spinning around right now at this speed that we told him to, and his clones are going to be following this instruction. So until we get the clones going, you're not actually going to see this movement. So unfortunately, I can't preview this for you yet, but let's keep going here for a little bit more. So as I was mentioning yesterday, it's a little bit before we see anything actually happening here with these guys, so you got to bear with me. Let's get a little bit more code done, and then we'll take a break. I also mentioned yesterday that we've made this game kind of modular. There's different pieces that do the different functions. We're using that create my own custom blocks function to kind of take parts of the program and shove them off into little sections that are very logical. So we're going to have one for getting the enemy set up to go on the screen, one to make them fly onto the screen, one to make them hover, and one to make them fly away again at the end. And so we're just gonna set that up right now. Let's go grab under our control blocks. We'll grab a when I start as a clone. And this is kind of the skeleton for what every single one of these guys is gonna do. The first thing he's gonna do is show. So let's go to our looks command and we'll go show, which will tell them to stop being invisible. And now we're gonna grab those 4 custom blocks. We don't have time to set them up yet. So we're just going to go create them right now to get them into place. So I'm going to click on that red button at the bottom that says My Blocks, and I'm going to make some custom blocks here. So the first one here under Make Block, we're going to call this Initialize Enemy. Don't worry too much about the spelling. No one's going to see this but you. Initialize Enemy. You guys can look at this on the screen if you want to see the spelling. Initialize Enemy. All right, that's going to get our guy going. So we've got our custom block here. We have to tell it what the contents of this custom block later, but for now, we're just going to put this on the side, and we're going to set this block up here. So after we're done initializing the enemy, the next thing we're going to do is fly onto the screen. So let's add another custom block that's called Fly Onto Screen. I'm going to go OK. Now we have our second custom block of code here, and let's add the block underneath here, fly onto screen. And then the next thing we're going to do is hover. So let's go make a block that's called hover. Again, we'll tuck this over on the side, and we'll add the hover block to our skeleton here. And the last thing they're going to do after they finish hovering is fly away. So let's just type fly away here. And again, we'll take our custom block and move to the side, and then we will add fly away to our skeletal commands here. Okay, so this is the marching orders for our new robot. And there's one other thing the robots have to do before they get going. They're not robots. They're actually, well, I guess they might be robots. They're drones, right? We also need one more when I start as a clone here. Oh, I don't know if we really do. Hold it. Yeah, okay, I see what we're doing here. Because this has to start simultaneously, we have to get another start as a clone here to make one more thing happen, and that is we need to start checking for collisions. So I'm going to go when I start as a clone, forever. We're going to start checking for collisions. Now we could put all the code inside here, but Jeffrey has set this up with another custom block called test collision. And I've learned not to second guess him on these things. He might have a reason for this, so let's not, let's just do what he suggests here. So test collision, I'm creating another custom block. Once we get all this set up, we can start moving on the coding pretty quickly here. So when I start as a clone, forever, test collision, there we go. Okay, I'm gonna take a little break now, and then we're gonna start filling in some of these blocks, and we might actually see some motion on the screen in a second, so looking forward to that. Okay, we're back, and we're ready to do some more coding. So let's get over to start working on some of these custom blocks of code and what their contents are going to be. All right, we're going to start with Initialize Enemy, which makes sense. So right now our enemy guys are cloning themselves and appearing in the middle of the screen. The first thing we're going to do is bump them off the edge of the screen, tell them to be facing in the right direction, and then we're going to launch them off onto the screen. So let's do the initialization part first, which is right here. So we need to just grab an if statement, control if, and we're basically going to say, so these guys have a costume. Let me show you their costumes here. So here's the one costume and another one. So they're going to be mostly flipping back and forth between these. And it's going to make them look like they're flying, like little angry bumblebees. The third costume is the beginning of our explosion, right? And the explosion is going to get bigger, and then finally our guy's going to disappear off the screen. So we're going to be changing costumes as things go, and we could keep track of whether this guy's alive or dead with a variable, but that's a little bit tricky because we're making clones, and then we're wondering which clone is it that got damaged and which one got killed, and that creates a whole world of headaches for you guys. So we're going to keep track of whether this guy's alive or dead based on what his costume is. So what we really need to do here is start checking and seeing if he's wearing an exploding costume. Then we need to start animating his explosion and delete the clone. Otherwise, we're just going to get him set up to start moving on the screen. It's a little bit confusing for you guys, but basically we need him right at this phase to test and see if he's dead or not before we do all the other stuff. Okay, so we need an if statement here. We need to say if, and we'll grab an equal sign, and we're just going to see if his costume is equal to something. So let's grab an equal sign, and we'll say if costume number is equal to 3. So we can grab that from our looks menu here. Right towards the very bottom of the purple looks blocks is one here that says costume number. So if costume number is equal to 3, then we're going to play the death animation. So again, Jeffrey's created one more last custom block for this. Let's go ahead and create one more custom block that says death animation. There we go. Okay. And we're going to deal with this one later, just like all the rest of those red blocks. And inside here, we're just going to play the death animation. So if our costume is 3 and we are in fact dead, we'll play the death animation. Otherwise, or regardless, we're going to point in the right direction. So let's go to our motion blocks. We'll grab point in direction 90, one of these blocks. And we're going to change it to point in direction... All right, so we're going to start with direction minus 150. We're not going to do it in here. I just want to show where minus 150 is. So we're going to have them facing down in this direction, facing down to the left, and then we're going to subtract a direction from them. So they're going to start from here and then go anywhere along a range in these directions here. So they're going to start by moving bottom left across the screen, but we're going to use a random number to determine whether they're going here, 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 or here. Either way, they're moving this way across the screen, left across the screen, okay? So we don't actually type a direction in here. We're going to put a random number in here, and it's a little bit complicated. First, we need a minus sign. So let's go to our operators. We'll grab a minus sign, and we're going to go point in direction minus 150. That was that bottom left I was showing you. Minus 150 minus, and then a random number from 0 to 60. So let's pick random from 0 to 60. And so what that is going to get us is it's going to pick a random number from minus 50 to minus 90, basically. And so they're going to sweep in one of these directions, basically. Okay. And then we want to push them over to the right, so they'll be ready to start moving. Let's go to our move blocks, and we'll go move minus 200 steps. That will take him right off the screen, and so that he's ready to go. Okay. Now, I think we're ready to do the fly onto screen, which is the first place we're actually going to see something happening here. So let's grab that prefab block called fly onto screen. There it is. Let's code this one, and then you'll actually be able to see something happening in your game. And I know you've been very patient here. So first thing we want to do is switch our costume to costume 10. Let's have a look at costume 10 here and see what that is. Costume 10? That is not making any sense. Woo. That's probably costume 1, eh? Yeah, okay. So I think that might be a typo or something. So let's go switch costume to costume 1, because he's going to be wearing his... Oh! Look at that. The first costume is called 10, even though it's costume number 1. That's what confused me. Okay, so we're going to put on that costume. We should have really renamed those, but it's a little late for that now. Okay, so now we're going to start doing those swirling motions. It's a couple of different repetitive motions, and we'll just go through it one by one. So let's start with the repeat loop. We'll go to Control, grab a repeat 10 block, and change that number to a 2. All right, now we're going to get it to move somewhere between about 50 to 100 blocks or so. So I'm going to go grab another repeat and put it inside. And we're going to repeat a random number of times. So let's go to our operators. Every time these guys swirl onto the screen, they're going to do something a little bit different, and that's why we're putting random numbers into their motion here. Okay, so pick a random number from 5 to 10. From 5 to 10. And inside this repeat loop, we're going to say move 10 steps. All right. These guys aren't showing yet, are they? Hold it. So when we go, I just want to have one look. Oh, they do show. Okay, so let's see if anything happens yet when we click the green flag here. And our guys, there we go. So they're all spawning at random spots on the screen, and you can see that as soon as the game starts, they swirl onto the screen and come in towards that central direction. So that's the first thing we programmed to do. Let's look at that one more time. So they come off the top of the screen and then they start swirling around. So let's go add the next step. So that was what we added here. They're basically picking a random, let's stop this. They're basically picking a random number and moving a random distance in the direction that they were told to go before. Okay, so let's do the next phase of the movement. We'll grab another if statement here and put it, so the next if statement is still inside the repeat 2. So we're going to put that underneath the repeat 1 here. And we're basically flipping a coin here. We're going to get them to either swirl to the left or swirl to the right here. So we're going to grab an equal sign, and we're just going to do the equivalent of a coin flip here. We're going to go if a random number between 1 and 2 is a 1, so one side of our coin. So let's grab a random number and put it inside the equal sign if, let me save my file here. So if a random number between 1 and 2 is equal to 1, then we're going to swirl around to the right. And there's a bunch of commands here we have to do that. First of all, we need another repeat. So we're adding some more randomness in here. The craziness just continues. So let's grab another repeat. And we're going to repeat a random number of times. So Jeffrey tested this out and tried a bunch of numbers, and these are the ones that worked the best. We're going to go pick random from 13 to 36. And that will get him spinning around enough that he's really moving fast, but not so that he'll fly off the screen yet. Okay, from 13 to 36, and we're going to go turn 10 degrees and then move 10 degrees. So let's go grab our motion blocks. We'll go turn to the right 10 degrees. And then we're going to move 10 steps. All right, before we test this, oh darn it, this was an if-else command. Okay, I did it again, guys. So we're just, every once in a while I forget these if-else commands. It's kind of my trademark now. I'm just going to take this if statement out and replace it with an if-else. They look exactly the same when you look at them in the code reference, but you have to look down deeper into the code to see whether it's an if-else, and I'm always forgetting. So inside there, we're going to put our pick random from 1 to 2, and inside the if statement, we're going to put all the rest of that stuff we pulled out. So this is what it should look like now. Sorry again for leading you guys astray. So if the coin flip lands the other way, which is the else, we're going to do another repeat thing here, and I think we can use most of this code again. So I'm going to move my cursor over the word repeat here. I'm going to duplicate and drop all of this stuff into here. And we just want to flip around the rotation here. So I'm going to grab a different rotation block. I'll go to motion, and I'm going to grab a turning in the other direction command. Now I have to get rid of the first one. And we're going to turn 10 degrees in the opposite direction. I noticed here that I put 101 degrees instead of 10 degrees in this first repeat loop, so I'm just going to fix that as well. I don't know if... so let's test this out one more time. So a lot of this code isn't really going to be making a lot of sense to you, but every step that we add, you'll see that there'll be a little bit more complexity in the movement of our guys. So now they're going to come down off the screen, and now you'll see they do their first little swirl around here. So now that's cool, you see? So they go flipping in opposite directions, do a random kind of rotation twice, and then land in their final spot. And here comes some more of them. And you can see every level there's going to be more and more of these guys coming in. Here's level 3. Now there's 15 of these guys coming down. Whoa! And it just gets more and more and more. So they're not done their movement. That's just the first stage of their movement, flying onto the screen. After that, they're going to hover, and then they're going to go fly off the screen as well. I'm just going to take a short break here, and I will be right back. Okay, guys, how's that working for you? So I'm not 100% sure we're going to get this done in part 1, but we're making good progress in part 2. So I think we're going to get done here in 2 parts. Let me save my file, guys. So that was one of the questions being asked in the forum. Is Avi here yet? I wanted to ask him if whether it was okay to show his Donkey Kong remix, but it doesn't look like it is. So unless I hear from Abby, I think we have no remixes to show today. It's a slow Friday here at Cromer's COVID Computer Camp. Last call. You guys are a very quiet audience today. So let me just have a quick look at what we're doing next here. So we're flying onto the screen first, and yeah, now we can do the hover, and then we'll do the fly away. And did I put the test collision down here? We just haven't done the code for it yet, eh? Let me just have a look at what we've done and what we haven't here. Test collision, and we don't have the actual code. It's just a custom block here. And where is the defining block for test collision? It's right here. Okay, we're ready to go.
Mr. T?
Yes? Maya?
I was just seeing in the comments, but Eric says it says 101 in the turn, not 10.
Yeah, I actually caught that error, Maya. Just before the break, I noticed that and I mentioned it. But that was actually a really good catch, Eric. You did find an error, but I spotted it before I noticed your mentioning in the chat. So sharp eye there, Eric. Sharp eye. Good work. All right, so let's start working on the... after fly onto the screen, it was going to be hover. So let's work on the hover animation now. Okay, guys, we're back. So our guys are flying onto the screen successfully here, and now we're going to do the hover animation where they hover, and some of them are going to be shooting down while they're hovering. They'll stay there for a couple of seconds and then fly off the screen. So let's do the code for that. I've got my defined block here. Let's just get onto the screen. So I'm still inside drone 1 here. I've got my defined block called hover, and let's pop in the code for what they're going to do while they're hovering. And this is where they're going to attach themselves to that grid that we created. So let me show you how that works. First thing we want is make sure that these guys are in costume 1. So let's go to our looks menu. We'll switch our costume to costume 1. And so costume 1 is not actually the first costume. The naming convention here is a little messed up, but so their wings are open or flapping when they're flying, and then when they land, they close their wings up like that when they hover, and then when they start flying, they move their wings back out again. It's the way that it works. Okay, so switch costumes to costume 1. Then we're going to point in the direction. So let's go to motion, point in direction, which is this block right here. And we're going to change that number to 180, which is straight down. We're going to make sure these guys are facing downward so that they can shoot us. Well, these guys aren't going to shoot, but drone 2 will shoot us. And now here's where we attach them to the grid. We're going to grab a variable here, and we're going to grab the command that says set variable. And we're going to set enemy X. So there's a new variable we're using here called enemy relative X, and that's going to be basically how far away are you each. This is a message that's going to every clone, right? So the clone's asking, how far away am I from that reference X, the guy in the middle of the screen spinning, right? So how he's spinning and moving to the left and moving to the right and moving to the left and moving to the right, and every time he moves left, our clones are going to move left too. So we have to basically say, I'm moving left and right and staying this distance away from that enemy grid, basically, and every one of them will have a slightly different distance from the grid, right? So let's go set enemy relative X to, now we need a minus sign, so let's grab some math here, and here is a minus sign. So we're going to say set enemy X to X position, which is the current X position that your clone has. So let's go grab that. X position minus enemy grid X, which is where the guy is right now on the screen, the central guy that we're grabbing a reference from. So I'm going to go to my variables. I'm going to grab a bubble that says enemy grid X. So this won't really appear to be doing anything. Let's just add one more block and then you'll see what's going to be happening here. So they're going to swing to the left and swing to the right. And they're going to do it for a certain amount of time, and that's going to be determined by this repeat that we're adding here. So let's go to our control blocks. We'll grab a repeat. And we're going to repeat between 60 and 120 times, basically. So we're going to grab another random number. We're just trying to randomize all the elements of this so that these guys look like they're moving differently each time. So let's go repeat from 60 to 120. And what we're repeating there is our movements left and right. So they're going to be hovering a different amount of time every time. And then when they're done that, the hover will be over and they'll fly away. So let's go set X. We're going to go to our motion blocks. We'll grab a blue motion block here that says set X. And we're going to set X to, we need to basically take where that grid is and add our offset, the amount that we're different from the grid, basically. So let's go grab a plus. We'll go to our operators, grab a plus sign, which is right at the top of our green operators, and we'll say set X to, back to our variables. It's going to be enemy grid X plus our relative distance from that grid, which is enemy relative X. So this is going to get these guys moving back and forth. Let's give it a try. And so you'll see as soon as they spin onto the screen, they're going to start floating to the left and to the right. There we go. And so it looks like they're kind of moving like an army until they're done, and then they're going to fly down. Let's look at the next group here. So again, they're hovering left and right together for a while until their timer runs out. And it runs out differently for each of them, right? So some of them are going to start flying down before the other ones. And that's what that random 60 to 120 is. It determines when you're going to stop spinning and actually fly down. And that way they won't all fly down at you at once. They'll take turns flying down at you. Okay, so let me stop that, save my file in case anyone needs to get into it. And I'll take another really quick break to see if everyone's good here on YouTube. All right, we're back now. So our enemies are done hovering. Now we can tell them to fly away randomly when they're done. So let's go grab that block that says fly away, and we'll start coding it in a nice blank space down here. All right, the first thing we're going to do is switch our costume. So let's switch our costume back to the default costume, which is costume 10. Now we're going to point towards my ship. So I'm going to grab a blue motion command that says point towards mouse pointer, and I'll modify it to say point towards ship, or my ship. That's going to make our enemy fly right kamikaze style right at our ship if we don't move out of the way. Now let's grab a forever. And we're going to go forever if touching edge. So we're just going to delete him in case he flies off the screen, which he'll do eventually. So let's go if touching edge. We'll go to our sensing blocks and grab this block here that says touching mouse pointer and change it to touching edge. There we go. So if we're touching the edge, we're just going to delete this clone, which is under control here. Delete this clone. We're good. All right. And now we're just going to do our movement here. So we'll grab a move 10 steps. We're putting it inside the forever, but outside of the if statement. And we're going to have them turn every time they move. So we're going to add some randomness again. Let's grab a turn right command. And inside there, we're going to put a random number, which is going to be, so let's go to our operators. We'll grab a pick random. And the numbers we're going to put in there are anywhere from -14 to 14. All right, let's see what that looks like. So they're going to be moving, so they're going to start moving towards us, and then they're going to start to swirl and move and spread themselves out. So even if you duck from them, they might still turn at the last minute and hit you, which makes them even more dangerous if that is possible. Here we go, let's look. They swirl on, they sit for a second, and then they fly at me. Whoa! And you can see, yeah, that's pretty cool actually. So they start to swirl towards you. So let's wait for these guys again, and I'll just move out of the way at the last second. And you can see because of the randomness in their movement, you can see that even if I duck out of the way, sometimes they duck out of the way, and it kind of seems like they're almost following you. It makes them seem extra dangerous, doesn't it? Whoa! And it's quite difficult to stay out of these guys' way, so you're going to have to be shooting them rather than ducking them if you want to stay alive in this game for long. Unfortunately, we have the ability to shoot, but these guys don't have the ability to be shot left, so we'll have to get onto that soon. All right, so that's looking good so far. So there's our fly away. How do we get these guys killed by the enemies? So that's probably something else that we could add right now as well. So we've already got the test collision going. What are our other blank blocks that we haven't added yet here in Drone 1? Let's go have a look. So we've still got a few more custom blocks. So we haven't done test collision, we haven't done death animation. So our guys are moving properly, we just have to kill them now. So we're gonna need to fill in these 2 custom blocks to get that working. So I don't know if it really matters which we do first. So let's go with death animation, which is the shorter one. And in here, we're just going to get them to go through their costume. So they're going to start on the first death costume and then cycle through them. So to do that, we'll need a repeat loop. Let's go to our control blocks, grab a repeat 10 times, and change it to 2. There we go. So now I'm going to, inside there, just have it cycle through its costume. So let's go grab a wait before he changes costumes. I'll have him wait just 0.1 seconds. And then we're going to go next costume. So he's already on the first explosion graphic. Well, let's go to our looks menu, and we'll go next costume twice. So he'll go to the number 2 and number 3, and when he exits out of there, we will delete the clone, which will kill our guy. So let's go delete this clone. And now, one last set of blocks here, and then we will be ready to start wreaking some havoc on the alien hordes. Looking forward to that. So test collision is the next little piece that we're going to be doing here. I'm going to turn the page. All right. So this is where it's a little bit confusing. We're checking to see what the costume is. Oh, okay, we're saying if I'm not exploding already, and I'm touching a missile, then we're going to explode me. So we need an if statement with 2 different conditions. Number 1 is we're checking to see if we're exploding, and we're going to do that by seeing what costume am I wearing right now. If I'm wearing a costume 3, I know I'm exploding. If I'm wearing a costume 2, I know I'm not, or a costume 1. So let's go fill that in now. I need an if statement. Is it an if else? No. So just an if. So we'll drag an if into there, and we'll say if, and now I need an and. So let's go to our operators, and we'll grab an and statement. So we're testing for 2 different things, as I said. Number 1, we're just trying to see if we're touching a missile. So we'll go to our sensing blocks and grab a touching, and we'll change it to touching missile, or my missile. So if the bad guy is touching my missile, and our costume number is less than 3. So let's go grab a less than sign out of our operators. And remember, that's the arrow facing to the left. If, and now we need a costume number. So let's go to our looks menu. We'll grab costume number. We've already used one of these today. It's just this little one down here. If costume number is less than 3, which means if we're not exploding, then we're going to do all the stuff that has to do with us dying. Number one, we're going to change our score. So let's go to our variables. We're going to change score by 1. We're going to switch our costume to an exploding one. So let's go to our looks menu. We'll switch our costume to the one inexplicably called 0, which is actually the first exploding graphic. So it's costume number 3, but it's named 0. Isn't this confusing? If you really want to fix this up, we could go and rename all these. I could call it 1, 2, 3, 4, 5, but I don't want to break the game, so let's just keep going with this. Switch costume to 0. Create a clone of myself. What? Create a clone of myself is what we're going to be doing later. Ooh. Okay, I'm going to follow this code here. I think what we're doing is we're making a clone of ourselves so that we can turn it into a bullet later if we want to, or... Oh, no, this has to do with creating an explosion version of yourself, right? I think we're deleting... I'm not quite sure how this works. Let's put this in and maybe it'll make more sense when we finish doing the code. So switch costume to 0, create a clone of myself. This is the part I'm not quite clear on. Why are we making a copy of ourselves here? We're going to play a sound here. So let's go to our looks menu or sounds menu. We'll go start sound called hit 3. And then we're going to delete the clone. So why did we make that clone is an excellent question. Delete this clone. So I know later on we're going to be making clones of our bad guy so that they can turn themselves into bullets and we can keep track of where the bullets are. But I'm not quite sure why we made a clone there. Let's see what happens here and see if we have an extra bad guy running around after we shoot them. So now we should be able to commit mayhem. Let's give it a try. I'll click the green flag. I'm moving around. Ooh, my game has frozen. That's not a good sign. Let's try that again. Ooh, I'm creating clones like crazy and I've broken my program. I have a feeling that clone thing is not supposed to be happening. I didn't understand why we're doing it in the code, but I'm gonna have to go back and look at the master code here, and my Scratch has totally crashed now. I have introduced, is it? Sometimes if you really...
as well.
Yeah, wow. So we have a bad bug that we've introduced in the code here. I'm going to, as soon as we can get out of that, sometimes if you mash the stop key, that will fix your problems, but it doesn't appear to be happening. Does everyone else have that problem? Eric says he has that problem as well. Wow, we have completely crashed out Scratch. All right. Wow, I have never seen a game-breaking... Oh, here we go. So if you wait long enough, you get a game unresponsive message. If you want to keep trying, you might be able to hit that stop key and get your game stopped, or otherwise you can exit the page and reload it. Now, the risk we run there is we might be losing some work if that happens. I'm going to gamble here and wait, because sometimes if you keep mashing that stop key, as I said, it'll get out of that endless loop. No. But it seems like we're not. All right, so this is a bad thing, guys. We are going to be a little stuck here. Okay, so I'm actually going to call it now. It looks like we're probably not going to get to part, we're going to have to take it to part 3, guys, because we have 2 more drones to do. And all right, so I'm going to go exit pages now and see what we can do to recover this. Let's reload and see if we lost any work. So see inside. Wow, that was a nasty one. Let's go back to my drone 1 here and see what's happening inside him. So did I get my death animation is done? My test collision, is that completely done right now? Drone 1. Test collision. No, so I kept some of my work and lost a little bit of it here. And I don't know where you guys are, whether you lost some work for me either. So what you're going to have to do is we're going to just wait for your page to report that it's unresponsive. Go exit page, load scratch up again, and see if you lost any work. You probably haven't lost much, but you might have lost a little bit of this test collision script. Let's I'm gonna try and get this game stable to the point where you can test it out and shoot guys, and then we're probably gonna call it a day here. But I at least want to make sure that this doesn't keep crashing you guys before we leave here. So I'm going to try removing this delete clone. Let me go back to my code here while you guys... So I'm going to leave this on the screen. If you guys are relaunching, you can try and imitate what I have here, because you might have to rebuild some of this code again. I'm just going to go ahead and add a few of the things that got missed. So I'm not going to say create a clone of myself. I am gambling that that is what made this crash. Let's go start the sound. Start sound, and that's going to be hit 3, and then I'm going to go delete this clone. That's all should be inside the if statement. Sorry, switch costume, and then delete this clone. So let's go under our control blocks and say delete this clone. Now let's see if our game crashes again. Let me save just in case so we don't lose all our work here. If anyone's stuck, by the way, so you can get back to my code again, I've saved it. Now let's try playing one more time and see if it crashes the same way. Whoa. So that did not work properly. So am I missing something in my code here? Let's go have a look at this, guys. I'm just going to do a little audit here. I'm going to come right back. Everyone is watching this in the edited version. I'll talk to my audience here and we'll see if we can find out what I've missed in the code. It's obvious that I've just a little bit of code somewhere that I haven't added. So let's go have a look and see where I went wrong. Okay, guys, so we put our heads together and came up with a solution. I'm going to credit Chris Copeman with doing a fantastic job. I don't think this is the final solution to the problem, but for now we've come up with a workaround that seems to solve it. It was all tied into where the enemy costume is, and since he was wearing the wrong costume, he set himself to explode. So for now, I'm going to give you a fix. So inside the define hover block here, we're going to switch our costume from costume 1 to costume 10, which will make him wear a costume that's not an exploding costume, which will mean that he won't trigger his death at the wrong time. Now, that's not the way the code's supposed to work. I have a feeling there's something wrong somewhere else, but I am going to play around with it, and on Monday, when we do part 3 of this, I will have an explanation for you. But in the meantime, let's test this out, and I will confirm for you guys. Did I change that? Yeah, that's the right costume. So I will confirm for you guys that this is actually working now. So I should be able to shoot my enemies now. Yes, they're dying. There we go. So at least you guys will be able to play a little bit of the elementary version of Galaga with the one kind of enemy over the weekend. Yeah, this is working nicely. And then we'll add the other bad guys and some other functions probably next week. So that's looking good. All right, I'm sorry about the confusion, guys. There's something here that I missed, and I just need to spend some time looking at my code and figure out what's going. But at least we've found a workaround. Thanks to Chris for that. So, so we're done here for today. We're going to add 2 new enemies on our next session. One that shoots at us and one that shoots directional enemies at us, or directional bullets at us. It's, as I said, this isn't quite like the Galaga game that you're familiar with, but we're going to add some cool stuff to it. So we'll get to that next time we meet. In the meantime,